station and space to ground.
Welcome to Space to Ground. I'm Kayla France. This week, the orbiting laboratory welcomes a new visitor with lots of new supplies.
Liftoff of Antares.
On Saturday, the Northrop Grumman CRS-14 Cygnus spacecraft successfully launched from NASA's Wallops Flight Facility in Virginia. Carrying nearly 8,000 pounds of hardware and supplies, this mission marks the 14th flight of Cygnus as a commercial cargo provider to the International Space Station. After a journey of 56 hours, Cygnus reached the orbiting laboratory, and NASA astronaut Chris Cassidy used the station's Canadarm2 to reach out and grab the vehicle, allowing ground teams to maneuver and berth the spacecraft at Unity's nadir port. The cargo craft, named the SS Kalpana Chawla in honor of the first woman of Indian descent to go to space, will stay attached to the space station until mid-December.
Meanwhile, at Baikonur, final preparations are underway for the next flight to the space station.
NASA astronaut Kate Rubins and her Russian crewmates are concluding their pre-launch activities before launching from the Cosmodrome for a 6-month mission aboard the orbiting lab. This flight, scheduled for liftoff on Wednesday, will be quick. The time from launch to docking will be just over 3 hours, about the same time it takes for a commercial airliner to fly from Seattle to Minneapolis. Be sure to tune in to NASA TV and the agency's website on October 14th and follow the flight.
Space to ground.
Also, we invite you to check out the latest edition of Houston, We Have a Podcast. Before her upcoming mission, astronaut and microbiologist Kate Rubins sat down with our Gary Jordan to talk about a wide array of subjects, including being the first person to sequence DNA in space.
This week's question comes from Guy Etheridge, who wanted to know if a powerful speaker inside the ISS mounted to an inner wall, cranked up to 11, could create a measurable thrust against the ISS.
This is a very interesting question. In short, the answer is no. A speaker producing sound waves could not be used to create thrust against the ISS or to move the ISS. We move in space by creating pressure through ejecting mass. Newton's third law tells us that every action has an equal and opposite reaction. Thus, we can create thrust or movement in the opposite direction when we eject mass out of an engine. We can see this in the rocket thrust equation. A sound wave can be referred to as a pressure wave because it consists of a repeating pattern of high pressure and low pressure regions moving through a medium. However, in order for sound to move, it has to have a medium in which to pass through. Since space is a vacuum, it will not be able to propagate out of the station to create movement. The sound from the speakers would produce vibrations throughout the whole of the ISS that our sensitive sensors would likely detect. But since mass is not being ejected from the ISS due to the pressure of the sound waves, it would not be able to create movement or measurable thrust.
Keep sending in your questions using the hashtag AskNASA. We'll see you next time.